in the last session, we started off by talking about classes, which basically where we highlighted that where the blue started talking about classes as blueprints, and basically it's like user-defined data types. And we highlighted that classes give us the object-oriented features, right? And we said class do have members. So to get access to these members, you need member access specifiers. And then these were member access operators. And then these members can be specified as either private, protected, or public. So we have three options for specifying these numbers. So you can think of them as categorization, more or less. So the keyword to create a class is actually using the class keyword and then followed by the user given name. And then in this particular case, we are specifying these numbers to be public. So that's the keyword we are using. Now, the main point being that a public member can be accessed from outside the class as long as where it's being specified from is within the scope of the class's object. So basically an object is an instance of the class, and the example that we used were two boxes, and that was created earlier, and then later we used cars. And these cars we created both public members, and mostly they were variables. And we used the access operator, which was the dot, to get access to the variables once we create an object of the class. To create an object is quite similar to the way we create variables. Like we have our data type called car, and then this is the object or an instance of it. So pretty much just a recap of things. And also we have mentioned that we can have functions as members of a class. So if you create the function, you can actually inline the definition, or you can use the scope operator. So the scope resolution operator, which is just two semicolons, to get access to the, so you have the name of the class and then you get access to the function, then you can follow on with the definition of the function. So we've got an example where we have the inline specifier. So it's inlined here. In terms of when we create the class, we put the whole definition there. And we've got another option where we are using the scope resolution operator to define the function. So that's an example. We have tried definition of double being outside the class in there. But anyway, let's just carry on like that. So we've run through this example. I think one thing I really want to emphasize on is the benefits of the public, private, and then the protected specifiers. Basically, it's a way of hiding some aspects of your code or most important parts of your code. So pretty much we all put things in houses that we don't want just anyone accessing, or you can just also things that you want people to see. I mean, I always use Facebook example as example, for example, things you want people to see, great, you just can make them public. But with people protect things or make some other things private for reasons, right? So we have, a class can have multiple of these specifiers. You can have multiple public, undo that. So you can have multiple public contents we have seen before using the variables and also the function that was created, and you can have protected or private as well. So you have multiple of these specifiers. Then we did mention that the public members can be accessed anywhere from the class as long as it's within the scope of the class's object. But the protected, the private members can only be accessed by variables or functions that are within the class, right? So basically, so as long as you've got a member function that is part of that particular class, they can actually access them. And also, they can also be accessed by friends of the class. We'll look at some object-oriented features today. I think we are just going to look at derived functions or derived classes, and you can actually look into the rest yourself as well. Or we've got protected members. These protected members, similar to the private ones as well, but they can be accessed by the child of those classes as well. So remember, private, either the class only from within the class itself, or friend of the class. So friends can access private stuff. And also we are protective of our family. So if you think about it, then protected members can be accessed by the child. So I asked you to walk through a few examples, several of these, and I believe that the only one that sets itself apart was the this derived class being created here. So we've got a class called box, right? So box is pretty much going to have a child, right? So box is going to have a child like its relative, and which is basically another class, which we call small box. And this column there actually shows that it's more or less this small box is actually kind of absorbing this big box. So this small box is actually a child of the big box, in the sense that its protected members automatically become part of this small box. So pretty much, if you're born into a house, you get access to that house, more or less. If you are considered a member of a home, you are pretty much part of that home. You share things that are shared among the home, or as long as you're considered as part of the family. So it works the other way around. I know it's quite strange to see the parents as a subset of the child, but pretty much kids inherit parent stuff. So they get access to the protected members, which means if we have this double, we've got this double data here, which is the width, because we have created a child called small box. Inside the small box, we can also make use of the width. So this width, even though it's protected and part of only the box, so we can actually access that width through the small box. So we have a small box, and we've got a member function called, I don't know, get width, set width. So we can actually use the get width and set width to get access to this particular width. So that would take us to where we left off last time. So the easiest way to think of a constructor, so we're still talking about classes, right? You think of a constructor as like the default setting, the default function you want to run when you create an instance of a class. So let's say we have a car class, right? And which is what we've been working with so far. As soon as you create an object of that particular car, you just want to say, this is a new car. You've got 5 years insurance, 5 years warranty on the car. You just want to tell the user that this is a new car. You've got 5 years warranty on the car. So any car that comes out, you're going to paste that big sales sign on it right away. So these are sort of some of the default things we want to run as soon as an instance of the car of that particular class is created. Now think of this instance as what? It's an object of that particular class. So basically, just looking into it, we have this particular class called main class, and it's interesting. So we've created a class called main class, and as we walk through the class's definition, we see the name of the class within itself. Yeah, what this is actually a constructor, and you notice the constructor is pretty much a function. It's got these two closing brackets there. So this constructor is whatever is inside the constructor is the default thing we want to run as soon as an object of that particular class is created. So we're saying, okay, so it's public by nature. As soon as we create an object, we want this to be printed to the screen. So we call this constructor. It has exactly the same name as the class itself. So if we go into the main function, for example, so we've got int main class, which is an object of that particular class created, and then we say do nothing. So let's try that. I'm just simply going to copy and paste the code. So we get the liberty of running through a lot of this today. So we've got my class code we just explained. Let's try it out to see whether we get some errors or how it behaves. Doesn't like the number coding for that one. Right, so you notice in the main function, we have not used any CL statement, but as soon as we run the code, we got what? We've got new member object is created because what? As soon as we created an object of that particular class, the constructor was what? Called. Does it make sense so far? All right, so pretty much a constructor in a class is a special method. It's just basically a function that is automatically called when the object is of that class is created, as we have just demonstrated to you in a second, right? So basically, to create a constructor, you use exactly the same name as the class itself. Don't know when that happens, but exactly the same name as the class itself. And of course, you follow it by the parentheses. Parentheses just because it's what? It's a function, it's a method, right? So the constructor has the same name as the class, and it is always public. I think one thing it's always public, and it has the same name as the class. And of course, it's called automatically as soon as you create an instance of the class. We've looked at the constructor, which is the function that is called automatically when the class, an object of the class is created. And you're thinking of the way that when we create variables, we actually creating a memory space, a space in memory to hold that variable. Same way you create a class, it's going to occupy space. So when the class is about to exit, when object of the class is about to exit, in terms of you've called it, is being created, and you want it to be destroyed, you want to destroy that object, then it's going to free up memory space. So you use you've got a constructor, which is creating the object at the point of creating the object, and then you've got a destructor, which is the function that runs at the end, at the point where your object is being destroyed. Okay, now it's not just the object of the class itself, also a pointer to that particular class. Yeah, pointers points to the memory location. So let's look into it. Pretty much a destructor is a special member function, or again, another member function of a class that is executed whenever the object of that class goes out of scope. So it gets being destroyed, or you're freeing up that memory space, or whenever the delete expression is applied to a pointer to that object, the object of that class. So basically either the object is exiting in terms of its execution, or basically you are deleting a pointer to the object. Good. So a destructor will have exactly the same name. So it's pretty much similar to the constructor. They both have the same name as the class, but it will be preceded with this tilde sign. So you've got your constructor keyword and then the destructor keyword, just because of that tilde sign, just shows that you're actually getting rid of something. So they can be really useful, especially if you are coming out of the program or closing the file, releasing memory, say like file closing or something like that. Yeah, pretty much learning how to say banana in these languages. Okay, so we've got a class, and that particular, let me run it anyway, just before. Yeah, we've got a class called line, and in the class, you've got function that sets the length of the line. So you've got some setters and getters. We've already talked about these getters and setters at some point. And then you've got the constructor called line, and then also you've got a destructor for the particular line class. So if we go into the line class, so this is the line class, if we go into it and then we are looking at the constructor. When a constructor is called, that's as soon as an object of that particular class is called, we want to print out object is being created. So you see, as soon as we run, the object was being created at that point, because in our main function, we have line here, which is just the object of the class line with capital L. Then when it's exiting, we want to say object is being deleted. That's when the object is going out of scope. So by default, that is called after around this point. So we've got here, we've got the setters that sets the length of the line, and then we call out maybe line gets line length, and then basically we print that out. Let's try something before we go back, so we can actually see the point at which the object was deleted. And I will type object deleted there. And we see the difference. The object was deleted when the main function was getting out of scope at the point of the return 0. So it's not just when we call the objects, just when we are freeing up all the memory. So if the class was being accessed from another function, for example, is when we are exiting that function. So at this point, it's just mostly around this point when that class is being destroyed or all memories are being freed. So again, we've got a destructor there, constructor, destructor, constructor, destructor. Okay. Yes, please go ahead.
What is in line 16 and line 22?
What is
16 and like line double colon line void? Is it a function or what?
This is the destructor, what we just talked about 2 minutes ago.
This is not a function.
It's a destructor. Destructor is a function. It's a special function that is called when it's called automatically when the when the object of the class is being destroyed, or when we are freeing memory of that particular that particular object occupies. So it should be around this point. When we are exiting the main loop. You see, this was never explicitly called in the code. This line there. The same, this line was also called automatically, which is at this point we are saying the object is being created. That's the constructor. As soon as we created an object of the line class, don't confuse the capital and the small. As soon as we created object of the line class, we had that line printed out. Yeah?
It's
okay. So it's just constructor, destructor, like it's just like a villain and the superhero, and then a supervillain. They kind of
both line are constructor and destructor.
Yeah, it has to be exactly the same name as the class. So this is the class name. So they have to be exactly the same name. So just that
capital one is constructor and small letter one.
No.
Letter.
The constructor has to be exactly the same name as the class's name. They are both capital, but the destructor is preceded by the tilde sign.
What's this thing that you marked now?
Sorry, that's the tilde sign. That shows that this line is a destructor. It shows that this function is a destructor. So if I call this I don't know, banana, whatever. If I call this fruit, then the constructor also has to be called fruit. And the destructor also have to be called fruit. The class doesn't have to, so anyway, I have to change this to fruit. But the class doesn't have to be exactly the same name. So my class now is fruit. This can be orange or mangoes or apple or something like that. Yeah, it doesn't matter. As soon as I create I can change it through. As soon as I create this particular apple, the constructor of the fruit will be called automatically. Sorry. This line 7 here will run automatically. As soon as we are exiting the main function, this destructor will be called automatically. Yeah?
Yes, sir.
Okay. Ask.
Is it because why the reason as to why it has to be the same is because to make it the code
It's asking whether it has to be exactly the same name because to make the code readable. One, yes, it makes the code readable. And two, it's sort of the standard that C++ comes with. It's like a way that for the compiler, to help the compiler know that I need to run this particular function as soon as I create an object. As soon as I see a new object created, that function must be run. So it's a standard that comes with a C++ and also, okay? So we create an object. We're going to create this one. I'll call this object 1. Let's type this faster. Object 2, object 3, object 4, object 5, object 6. Okay, so I've got the line object 1 all the way to 6. Okay, let's do a quiz. So each time we create a new object, we expect the constructor to run. Okay, how many times will this line be printed on the screen this time if I run it? Object is being created. Object is being created 1, 2, 3, 4, 5, 6, 7. So we've got object being created 7 times and object being deleted 7 times. Does it make more sense now? So each time we create an object, so it doesn't necessarily have to be exactly the same name, this one. This is just an object. So each time we created an object of the class, the constructor was called. Each time it got deleted in terms of freeing memory space, the destructor was called. Yeah?
Can you explain line 20?
Line 20.
Yes.
Can you talk me through?
Yes, sir. We have created a data type double length. I didn't understand equal to len. This is the thing.
So where is len?
Is line 20 length equal len? Yeah, okay.
So where is the length in the class?
It's private double length.
Yeah. So
Yeah.
how can you access private members? You can use member functions to access private members, right? So it's just
Okay,
the
sir.
definition of these member functions. Yeah.
Thank you.
Okay.